Okay, eighth graders, we are doing section 4-7, the real numbers. So we have used many of these terms before. And this chapter, or this section, we are going to be classifying numbers. So when we classify numbers, there are a bunch of different levels. So the most inside circle here are the natural numbers. These are numbers you would naturally count with. So if I were counting like the desks in my room, I would say there's 1 desk, 2, 3, 4, and so on. And this goes on indefinitely. It does not include any negatives. It does not include 0. Does not include fractions or decimals. So the next circle here encompasses natural numbers, but then we're going to add one more number, and that is 0. So 0 is included in the whole numbers, but still no fractions, no decimals, no negatives. Okay, and then the next set is integers. So integers is where our negatives come into play. So the definition of an integer are whole numbers and their opposites. So this would be like -3, -2, -1, 0, 1, 2, 3, ... Okay, so still no fractions or decimals, but we have negatives there. Now, rational numbers. The definition of a rational number is any number that can be expressed as a fraction, basically, okay? So rational numbers include integers, whole numbers, and natural numbers, but they also include our decimals and our fractions. So for example, 7.5 is a decimal. That could be expressed as a fraction though. 16/3 is a fraction. -2.61. It's a nice decimal. It could be 61/100ths. This could be expressed. In this category, we'll also have repeating decimals like 1/3, or this could be 0.3 repeating. Like I said, we can have negatives, anything that can be expressed as a fraction or a decimal. We could have mixed numbers, so like 2 1/9. But there are some numbers that are not going to be rational, and those are going to be our irrational numbers, and there's only a few. Anytime we have a non-perfect square, so like the square root of 14, it's a nice number, but it's not a perfect square. The square root of 16 is rational. That would be over here. That would equal 4. Okay, but irrational would be if it's non-perfect squares, and then the other famous one is pi. So I could do like the square root of 27, the square root of, 19. The other thing is if I gave you a decimal that you did not know what was coming next. Okay, we don't know what's coming next. Okay, we don't know. That's irrational. So your job today is going to be able to classify numbers when they're given to you. And basically, you are going to determine if they are rational or irrational, and then you have to determine if they're rational, what kind of rational number are they. So the first one, square root of 3. Is that a perfect square or is that a non-perfect square? The square root of 3 is not a perfect square, so it's an irrational number. But we have to remember that all of these numbers are also real numbers. So we're just going to say irrational. -52.28. Now it's not a natural number, not a whole number, not an integer, but it is irrational. It's not irrational. I always say that rational numbers are predictable. Like we know that this ended, or we know what number's coming next. So letter C. Sometimes we have to simplify them before we can do it. So on this one, I see I can take the square root of 16. So the square root of 16 is 4. And 4 over 4 is 1. Okay, so 1 actually is under the natural number category. So that means it's a natural number. But if it's on the inside, that means that it's also a whole number. It's also an integer. And it's also rational. So we have to remember that if it's a natural number, it's going to be all 4 of those categories. Square root of 5 is not a nice square root. so it's irrational. Negative 12.75, it's not natural, it's not whole, it's not an integer because it's got that decimal, but it is rational, it makes sense. And then 3. 3 is just a nice number. So again, that's our natural, our whole, our integer, and our rational. So that's classifying. So the next category, they just want to know, is it rational, irrational, or not a real number? So the only not real numbers that we are going to encounter are negative radicals. So you can't square root a negative. So not a real number. And then if you divide something by 0, this is undefined. If you did this on the calculator, you would get undefined. So this is not a real number. So those are the ones that you guys are going to encounter. Square root of 15, you can't take that one. That was an irrational. So we would just say that this is irrational. And then this one, the square root of 1/9. Remember, we can split this up. Square root of 1 over the square root of 9. Square root of 1 is 1. Square root of 9 is 3. Well, 1/3 makes sense. You can have 1/3 of a pie or 1/3 of a cake. So that's not irrational, it's rational. So just because it's a square root of a fraction doesn't mean that it's irrational, because we could do that. Okay. The last little concept that I'm going to talk about is the density property of real numbers. And the density property just means that if we had a number line and I had 1 1/3 here and 1 2/3 here, that the density property states that between every two numbers, there's more numbers, okay? So the question says find a real number between 1 1/3 and 1 2/3. So the quickest and easiest way to do this, if these are right next to each other, to change it to the next, like to multiply them by 2's. So this is 1 2/6 and 1 4/6. Well, what's between 1 2/6 and 1 4/6? You could have 1 3/6 or 1, actually that's the only one. So 1 3/6. So 1 3/6 or 1 1/2. Now, that's not the only number, because we could cut this into smaller chunks still. We could have denominator of 12ths and find another number, but that was just the quickest way for me to do that one for you. Okay, so the next one, you have 3 2/5. And 3 3/5. So again, I said you can take and just multiply those by 2 and double. Cut those pieces twice as many times. So this could be 3 4/5 and 3 6/5. So what's between there? Well, 3 5. Oh, sorry, this should be tenths. What am I doing? 3 5/10, which would be 3 1/2. Now, I do just want to show you that one more time. I could change it. I could take 3 2/5 and 3 3/5, and I could multiply them by 3's if I wanted. And I'm just multiplying the fraction. So this stays 3 6/15 and 3 9/15. So then you could have 7/15, 8/15. You know, you have more options in between there. Oops, oh, I'm sorry, I wrote that and you couldn't even see it. 3 2/15, or 3 6/15 that turns into, and 3 9/15, so there's more options. So the more pieces you cut in this chunk into, the more options you could have for numbers in between there. But it's indefinite, it keeps going. You could cut that 100 times. So that is the density property.